Hello, in this lecture we will discuss about hooks and templates. So the goal or the outline of this lecture is the following. So we will look at hooks and template methods and what are they. We will exemplify them on two examples from the Faro core library, the print string print on case and the copy case. First of all, remember, when you send a message to an object, there is a choice. The system will select the right method to execute according to the receiver. And then each class you defines one possible choice. Self-sends are plans for reuse, and self-send defines hooks, places where subclasses can inject variations. And this is what we will revisit inside this lecture. So what is a template method? A template method specifies a skeleton with hooks. So here you have an example in a class. So this is an abstract class. And inside this method, template method, there are some self-send messages here. And if you look at it, the hook method 1 is a concrete method. So it means that there is a default definition inside the abstract class. But the hook method 2 is in italics. So this is an abstract method. Subclasses must redefine the hook method 2. And self-send messages, we already saw it in a previous lecture, they are hooks, places where subclasses can inject variation by redefining those methods. So this is the example that we already discussed. If I send the bar message to the obj, and obj is an instance of the class C, it means that here it will correctly return 42, because bar, this is a kind of template method, foo is a hook, and it has been redefined in the C class. Let's study this on a real example, real code from the Faro library. And for example, we will look at the print string implementation. If I send a print string message to an object, so here this is a delay for a certain amount of seconds. So here, for this delay, the print string method will return a string representation of the object. So it means that here it says this is a delay, an instance of the delay class, and the duration of this delay is this amount of milliseconds. So how is this print string method implemented? So in fact, it is implemented in the object class here. And there is a self-send, okay, that specifies the limit. By default, the limit is 50,000 characters. And if it is longer than that, it will be truncated. Okay, this is not really important. What is important is this method. And if you look at the code of this method, do you see the hook? Where it is? This is this self-send here, self-print on. And if we look at the implementation of this print on method, but before looking at the default implementation of it, let's have a look of sending print string to different instances. If I send print string message to a node instance, what it displays, this is a node. But if I send the print string message to an apple, it displays an apple. So we can see that the article here is different. And now we can have a look at the default implementation in the object class. So what does it do is that basically it will get the class name of the object, and then it will test if the first letter is a vowel or not. And according to that, it will display the correct article. This is the default implementation of print on in object. But now this default implementation can be refined. And let's have a look at the delay class, because the delay class, it displays the article, the name of the class, but also the duration. And where does it come from? It comes from the fact that the print on method, the hook, has been redefined in the delay class. And this is an extension of the default behavior because there is a supercall here. So we reuse the default implementation from object that displays the article and the class name, and then we extend it by adding the duration of the delay between parentheses here. Okay, so in the delay class we extended the default implementations of the hook print on. But we can go further. We can completely redefine the behavior of the print on. For example, for Booleans that you already saw in the previous lecture, if I send print string to a Boolean, it directly write a string representation of the Boolean. And since there are only 2 Booleans in the system, for example, for false, there is only one instance of the false class, which is named false. And on the false class, there is a redefinition of the print on method. And inside this method, it directly print false with a lowercase, because this is the name of the unique instance of the false class. Let's have a look at another example. For example, the interval class. Inside the interval class, the print on method has been redefined to display the start index of the interval, which is displayed there. Then the stop index of the interval, which is displayed there. And maybe the step of the interval there. Just by redefining the print on hook inside the interval class. Let's have a look at another example of the hooks and template mechanisms. For example, copying objects. Copying objects might be complex because usually there are a graph of objects that are interconnected all together, and there might be some cycles between objects, and each class may have different strategy to copy instances of themselves. A simple solution for that is to use the template method and hooks copy and post copy that we will analyze now. So let's have a look. In the object class, I have the copy method that is there, and the implementation of the copy method is this one. So the shallow copy is another method which is a primitive, and what does the primitive do is that it just copies the receiver and not its dependencies. So all instance variables or all things that are around this object are not copied, they are shared with the copy. But we have a hook there, another method, which is post copy. And there is a default implementation in object of post copy that just returns self. So we might think that it is useless. Why having a post copy that just returns self? And now we can analyze what we can do with that by extension with subclasses. Let's have a look at the bag class. So a bag is a subclass of collection. And a bag, if I have a bag B, this is implemented by having a dictionary in the bag. So here I have a dictionary. And the dictionary has some associations, for example, association 1, and an association has a key, key 1, and a value, value 1. And it might have multiple associations, etc. If I want to duplicate this bag B with another bag, B prime, there, and I want to be able to insert new elements or to remove new elements, existing elements from those two bags independently. I don't want to have too much sharing between them. And for that, I will redefine the post copy inside the bag, and I will extend it. So it means that I will copy the bag, B will become B prime, but I should also copy the dictionary, otherwise they will be shared. And I don't want that the dictionary is shared between the original bag and the copy. So it means that here I will recursively send a copy to the contents, which is a dictionary. So the dictionary will be copied. So my copy will have its own dict prime there. And now, is it enough? Because if I just do that, it means that the association will be shared. And if I change the value at a key, at a specific key, it means that it will not work. So we can have a look at the implementation of post copy inside the dictionary. And here we can see that in dictionary, this is recursively sent to associations. So associations are also copied when I copy a dictionary. So coming back from my previous drawing, it means that I will also have a duplication of association, and the only things that are shared are the real object. So it means that my two bags, B and B prime, are completely independent. I can insert new values and I can remove values. They will work independently. The only things that are shared are the real objects and the keys. So in conclusion, hooks and templates are a very common pattern. The template method sets the context, and hooks specify some variations that can be refined in subclasses. Usually, this is done by self-send. It means that we can provide a default implementation in the class, and this can be refined in subclasses. But sometimes this is not a self-send. Sometimes I can delegate by sending a message to another object, and it opens the space for dispatch. And this is related to the strategy design lecture that you will see later on.